Alright, so we're working on our checklist for Class 2 AT2. Continuing on that second page, the first clause that it references is C.1, which is that fire resistance that we were talking about earlier, isn't it? If I just find my mouse, just stand up so you can keep a track of everything a little easier. So you can see on the checklist it says C.1, type of construction. So we can go to section C for a start. That's a pretty fair guess. We can go there and see what we can see. But we already know we're looking at C1 first. That makes sense? Now there's a good chance that sometimes you might go to a section in the NCC and identify that there's 3 parts, but maybe one of those parts never applies. So if it happened to be the first one, we would just move directly on to the second section. But this one does apply, so we're going to look into it. So C1, fire resistance and stability, and we want to look at C1.2.4. C1. Now we don't want to look at the performance requirements and we don't want to look at the verification methods. We are trying to be compliant with the NCC. We're not looking for an alternative solution in accordance with the performance requirements of the regulations. We simply want to find out what the rules are and comply with those. We want to be deemed to satisfy. We're going to follow the rules. So these first 2 sections, the performance requirements and how to verify those alternative solutions, is probably something we can move straight past. So part C1, fire resistance and stability, if I open that up, and those verification methods are for the whole section, not just C1 or C2 or C3. C1 is our deemed to satisfy provisions, so that will be the overarching rules for the deemed to satisfy rule book that we are wanting to comply with. We'll have a quick look at it. It's often a bit of a nuisance to look at this part because all it does is say comply with all these rules. So it's a bit of a waste of time. We'll have a look at it and then we'll never do it again. It will basically say to be compliant with part C, you have to follow C2 and C3. It just says if you want to do what you want to do what you want to do. So it's not very helpful. So you can see here, our deemed to satisfy solution and the performance requirements in CP1 to CP9 are satisfied by completing all the other parts. But at least it gives you a roadmap to know which specific parts you need to go to. So you don't have to read the whole document. Because remember I said this covers 2, 3, 4, 5, 6, 7, 8 and 9. That's a lot of different building rules to fit into one booklet. And if you read them all, you might think they all apply to every class, which isn't the case. So this is kind of a way of keeping you out of the stuff that's not related to you. So you've got to do all of these. If you've got an atrium, you have to comply with this one. If you've got a 9B building, you have to comply with this one. If you've got a farm shed, you have to comply with this one. So it's just about the ways that you can do it. And then there's performance solutions and performance requirements. That's just the definition. These links take you to the definition of what deemed to satisfy is and performance requirements are, which I've already explained. It doesn't actually tell you what the performance requirements are. That's what the clauses do. So we're going to look at the clauses. So like I said, all that deemed to satisfy provision does is say, go here, and go here and read these rules. So I've already done that and we have them in the checklist. So we're just going to go there. So C1.1, type of construction required. So this is the minimum type of fire-resisting construction of a building that must be specified in table C.1. This is that table that we were looking at a few minutes ago. So they're referencing text and tables, quite common. You can fit more information in a table than you can in a sentence because you can read a table horizontally and vertically. And you can often really squeeze a lot more information. Remember I said they're all about making sure the document's not too big. So basically they're saying comply with whatever the table says. Now, what I am hoping I can, excellent. What we need to do is just determine what a story is according to the NCC. It'll be different for the planning scheme. What is determining a story for them will be different than what a story is for us. And here I notice there's a little link that says where the definition is. So I'm going to click on this link, story, and I'm going to read it and see how it applies to my building. So a story is a space within a building which is situated between one floor level and the next above, or if there is no floor above, the ceiling or the roof. So there doesn't have to be another story for it to be a story. It can be the ceiling or the roof. So that upper floor we've got is still a story, even though there isn't another accommodation above, it's just a roof. But if it only contains a lift shaft, a stairway or a meter room, it's not a story. If it only contains a bathroom, shower, laundry, toilet or other sanitary compartments, if that's all it has, it's not a story. If it has accommodation attended for not more than 3 vehicles, it's not a story. So if it's very small, it's not a story, according to the NCC, or a combination of any of those. So if that's the case, it's not a story. But we have more than 3 vehicles on our ground floor, so it's a story. And then we've got what is obviously stories above that. So how many stories is our building? What do you think, Andy? How many stories is our building? What do you reckon? Sharon, help him out. You remember from the elevations? We've got a 5, we've got a 4. Did you say 1?
No.
No? I thought somebody said 1. So we've got the car park on the ground, and then we've got 3 layers of accommodation, those sole occupancy units with 3 units per floor. 9 units in total. I reckon 4. Yeah. I don't think the roof counts as a story. No. If there was more accommodation up there, or if there was a car park up there, like if it was a really fancy drive-up thing, more than 3 cars, it'd be another story.
So you could have a rooftop terrace with a bathroom and shower, it's still not classed as it.
Correct, correct. There are still height limitations in the city and different areas, and that's not about stories, but the stories are in there as well. But yeah, you could, and it wouldn't be another story.
What about a pool or something like that?
Yeah, no, it's fine. Yeah, still not a story. But that would be quite deep. Still not a story. Although it doesn't say much about showers, so, pools. So that could be an exception. Or a mezzanine. Does anybody know what a mezzanine is?
Yeah, that's one of those things that hang overhead. It's just like stairs and something that sticks out you can store.
Yeah. So
you can see them in barns or warehouses.
Yeah, a loft or a mezzanine. It's not another story. It's like halfway between the roof and the floor. It kind of splits it in half without being a whole floor. It might only be halfway or a little way. It's good for study nooks. It's good for, a loft. If you've got a very steep pitch of a roof, you could have a mezzanine and just have some storage up there, or, that sort of thing. We don't do them so much here because it's hot at the top. It's too uncomfortable to go up there. But that's not a floor either. Excellent. All right, back to where we started from. So we've got 4 stories according to the NCC. So you probably want to make a little note of that on your checklist. See there it says C1.2.4, C1.2, 4 stories. Put a type in there, and what we're seeing is table C.1.1 has a list of stories. So for a 1-story type construction, for a class 2, it can be type C construction. For a 2-story class 2, it has to be type B construction. For a 3-story class 2 building, it has to be type A construction, and 4 stories or more has to be type A construction for a class 2. So this section in the NCC deals with the fire-resisting construction of all classes of buildings. We're specifically looking at class 2 for our project that we're currently working on, and it has to be type A construction. And that's about the fire-resisting construction. It's about how long the construction will last in the event of a fire. So A is the best and C is the worst. Yeah, you can just type A construction right next to that C 1.2 4 stories. Yeah, actually you're probably right. It probably needs to go on the left so that you can tick the box to say that the project is compliant. So what you'll end up with in the end is a whole bunch. I've got writing on the left of mine as notes for myself while I'm talking to you so I don't lose track of where I'm at. But you'll end up with a whole bunch of either ticks or the word compliant or see drawings or implement at construction stage. Just a way to address how this is going to be taken care of in the project. So it is currently 4 stories, so it must be type A construction.
Is it okay if I wrote it?
Yeah, you can write it there. Yep. I think in this instance that's probably the right thing to do because you're stating what it is. Yeah. Later on down the track we'll have stuff where we're looking for it and it'll either be there or we'll have to add it to the drawings. So if it's there, you can say compliant, and if it's not there, you'll have to say see drawings, and we'll actually change the drawings. Yeah, I think that's probably the best way to use this checklist. So if you were in the office and the boss came to you and said, I've got a set of sketches, can you check them against the NCC? This is your way of saying, yes on the drawings, it's okay, or no on the drawings, it's not okay, and this is what it needs to be. So you put the information of what it needs to be here, and you change the drawings as well. And then you would go back to the boss and say, this is my investigation, this is what I've decided is compliant or non-compliant, and then he might decide to further investigate or just go ahead and say, change it in the drawings. Yeah. Just having a quick look at the specification. I don't want to get too carried away, so don't worry too much. I'm just flicking mostly. All right. So there's a bit of information here in C1.2 about calculation of the rise in stories. We've kind of already taken care of that, so we won't worry too much. Some information about buildings with multiple classifications. So we've talked a little bit about that already. In this instance, for fire-resisting construction, if you've got multiple classifications, everything needs to be treated at the highest possible classification needed. So if you've got one part that needs an A, everything has to be an A. C1.5, 2-story class 2, 3 or 9C buildings. So it says here a building having a rise in stories of 2 may be type C construction. So we don't have a rise in stories of 2, we have 4, so this doesn't apply to us. But it's interesting because you can have type C construction if you were the right class and had to be a B or an A type construction, but instead of having that you just had more exits instead. You could have less resisting fire construction because it's faster for people to exit, so it doesn't have to last as long. So there's some contingencies. Just skimming through a little bit. There's quite a bit of information in here about construction under type C conditions, as is type A, but if you've got a lower building that can be type C construction, there's a little bit more data about what kind of construction materials and systems you should use. There's quite a bit of information in the NCC with regards to what materials are considered flammable and what materials are not considered flammable, and they apply a spread of flame index, which can be quite interesting to investigate if you want to really get into it. Most construction materials that are made of concrete or the gypsum that's in plasterboard are considered non-combustible, and timber obviously is combustible. So steel and concrete and gypsum are not so much. The biggest issue is the glues in some manufactured products. That's very combustible. Protecting fire, timber, sorry. All right, part C.2, here we go. Now just let me just check this. C1.10, Class 2 buildings to comply with Spec C110A and Spec 110A. Okay. Just going to quickly duck back. I've got a little note here on the checklist about C1.10. Let's have a look and see what that says to refresh my memory. (1.10), okay. Fire hazard properties. So this is where I was talking about the different assemblies. So the fire hazard properties of the following linings, materials and assemblies in a Class 2 to 9 building must comply with specification C1.10. So the floor linings and floor coverings, the wall linings and ceiling linings, any air handling ductwork, and the lift cars as well. Now you're not supposed to use a lift in the event of a fire, because if the fire department cut the electricity, your lift will stop halfway down. But you also don't want the lift shaft to transfer the fire from downstairs to upstairs. So it's about protecting the outside of the lift from catching fire too quickly. So they want to have the fire hazard properties, and I'll click on that so we can have a look at them. The fire hazard properties is about the properties of materials or assemblies, so multiple materials connected together to form a system, assemblies that indicate how they behave under specific fire test conditions. So there's all sorts of technical information here about radiant flux, and that's to do with the technical testing of how materials behave under fire. Spread of flame index is in there, and different smoke growth rates. So there are some materials which generate a lot of smoke, which can be not necessarily hazardous heat-wise, but visibility and breathing is really impaired. So they don't like a lot of smoke coming off materials either. So the fire hazard properties of the following linings, materials and assemblies in a Class 2 to 9 building must comply with specification C1.10. So if I click there, this is specification C1.10, which is about fire hazard properties. And there's different requirements for different areas and the different clauses within the specification that it talks about, and the critical radiant flux that needs to be below. So this is very technical stuff. This is mostly the fire engineer's responsibility. Floor materials, so the critical radiant flux of floor materials and floor coverings for different classes of buildings and the specifications they have to achieve, and whether they'll have a sprinkler or no sprinkler system. So once you get above 25 metres high in a building, you have to have a sprinkler system. So that changes the necessity of the different materials as well, because obviously if you've got sprinklers activated in a building, the requirement to achieve fire rating can change. Wall and ceiling linings, and some of the different categories of walls. So see all these numbers 1 and 2? They're the and 3, they're the group numbers of materials. So if I just scroll down here a little bit, I'm hoping I'll see what I expect to see. No, I'm not. So it'll be in a different place. Apologies. So there's a list of materials and which group of flammability they sit in. And then here you've got different classes of buildings and whether they're unsprinkled or sprinkled, and what groups the materials have to be in to be able to specify them. Now, we're not going down to that detail, it's just interesting. What we want to do is note the fire rating level that we need to achieve for the construction, so that can be incorporated going forward in the project. So there's a little note, there's basically a note on the checklist. Remember I said sometimes in a checklist you can oversimplify and forget things? So this note is relevant, but it's not necessarily something that we need to implement at this stage. So C1.10 Class 2 buildings are to comply with specification C110A and Spec C110. So that's the stuff we've just glanced over. I don't want to get too caught up looking at it in too much detail. All right, before we move on to C2, compartmentation and separation, I might just push pause there and let you guys go and have some lunch, and then when we come back, we'll pick up directly from here. How does that sound? All right, beautiful. It's okay. All right, C2, compartmentation. So like I said, compartmentation is particularly important when buildings are particularly large and full of people, because obviously if you can segregate the emergency or the fire, then less people are going to be affected. So the easiest example I can think of is Casuarina Shopping Centre. There's a massive sprawling shopping centre, multiple levels, and an opportunity for smoke and flames to be moved from one side of the building to the other side of the building quite quickly, but with perhaps without opportunity of stopping that, more fire than there needs to be. If it could be contained, that would be helpful. So next time you're at the shops, as you're wandering around, as you're going down the different corridors and around the layout, see if you can see any of those fire doors, the automatic ones, that are recessed into the walls that would come out in the event of a fire. So there are a few of them in the shopping centre. There's a chemist and a bank opposite one another right near the front, and just near there's one of those doors, and you can't really see it if you're not looking for it. But it might be near fire exits as well, so there might be some other fire equipment nearby, and you should notice a panel or a door where you can just see the edge of it, and it'll be quite wide, and it's probably on a hydraulic mechanism, and it will come out in the event of a fire. The other thing that you have for compartmentation is in the ducting systems, and Joanne, you'll know about this. In the ducting systems, there are panels that prevent the ventilation system from allowing smoke to spread through the ducting system. Yeah, so batters or baffles or panels that close. So they're the two obvious ways that you can compartmentalise. Now, if we're compartmentalising large crowded buildings, obviously the benchmark that determines whether it has to be compartmentalised or not is going to be the size of the building and the amount of people that can use it. So if we very briefly go here to C2, compartmentation and separation, you're probably looking at general floor area and volume limitations that decide whether we need to comply with these rules or not. So there'll be a benchmark, and if we come under that benchmark, we need it, and if we don't, we don't. Deemed to satisfy, we don't need. General floor area and volume limitations. So the first thing you'll notice is, and I usually go straight to the table because that's where the real data is, you can see the maximum size of fire compartments or atria or atrium, and then it's got some classifications. Class 2 is not even on the list. Now there's a reason for that. It's because the sole occupancy units are compartments of their own anyway. So it's not really a big enough floor area with enough people to warrant compartmentation and separation as far as those doors go. Those automatic doors that I was just talking about that are at the shopping centre, they might be in the cinema complex, they might be in maybe public hospitals, multiple floors, things like that. So you'll notice there's nothing about C2.2 in my checklist. So because I did this ahead of time, I've already checked that, and now I'm just confirming with you guys.
Yeah. So for this one, we can just put it
No, because C2.6 is still part of C2, but 2.2, 1 is not an issue, application of the parts, not an issue for us. C.2.2 isn't an issue. We've got C2.3, large isolated buildings. Now, the other thing that you might compartmentalise or segregate a building in fire is, so not only does the fire spread within its own building, but from that building to the next building. There's a clause there, C2.3, which talks about large isolated buildings. So if you're a large isolated building, the need to protect other buildings doesn't happen anymore. So there's some exemptions for those kinds of buildings. We won't worry about looking at it, but just bear it in mind. C2.4 is requirements for open spaces and vehicular access. That's to do with the fire emergency services access to the building, not just everyday car parks. Let's have a quick look at what that says. So if C2.4 is applicable, which it isn't, but if it was, then the spaces required for the use to get vehicular access would have to be certain sizes and in certain places. So you can't say, oh, a bit like we were with the easements, the neighbours have got space for the fire truck, so I don't have to worry. It's not really about that. So it's just making sure that you've both got the proximity to a fire brigade and the ability for them to get on site. If you've got a building that's inaccessible from the front and the fire is at the back, there's nothing that the fire brigade can do to help you. So it's about making sure that they've got access to the site so they can get in there. That will come into play for our Class 3, AT3 project, but we have an easement that they'll be able to use that coincidentally does help us out. So that's always handy. C2.5 is about Class 9A and 9C buildings. That's about healthcare buildings and how long it takes to evacuate sick people, because they're often connected to machines or they're in beds and they can't be walking on their own, or they might be unconscious. There's all sorts of that have to be taken in an ambulance. So the time it takes to evacuate a healthcare building is much, much longer than a typical home or office. So they have special clauses. Here we are, C2.6, vertical separation of openings in external walls. So I definitely know that one applies to us. So I'm just going to start reading from the top. Vertical separation of openings in external walls. If in a building of type A construction, that's us, any part of a window or other opening in an external wall, so if you've got a window or a door in the external wall of your type A construction building, if it's over the top of, above, another opening in the story below or above, so if your openings all line up in each story, in the vertical projection, and it falls no further, so if it's closer, see, if it falls no further than 450 outside the lower opening, which means if it's closer, if the top of one and the bottom of the other are close together, then the openings must be separated by either a spandrel, which is a horizontal projection that puts a big non-flammable concrete, typically, barrier between the opening below and the opening above, has to be separated by either a spandrel so we've got either a spandrel, the part of a curtain wall or panel wall that complies with the spandrel, or you have to have it further away, or there's your horizontal, sorry, I misspoke. A spandrel doesn't have to be horizontal, it can be vertical, but it has to be a certain distance. So between the top of the opening and the bottom of the next one, there has to be a distance, at least 900 millimetres, which you'll see on a diagram in a minute, that makes the gap between the top and the bottom further apart. That's a spandrel, or a horizontal spandrel as well. So that's this one here, a slab or other horizontal construction that projects outwards from the external face of the wall, not less than 1100 millimetres, and extends along the wall not less than 450 millimetres beyond the openings. So it has to be 450 millimetres wider than the opening that it's protecting. Now normally they go all the way around the building, so that's not really much of an issue. You don't start and stop them for every window. And it has to be non-combustible with an FRL of not less than 60, 60, 60. Alright, so this is the first reference we've seen of this. FRL and 60, 60, 60. Do a quick Google search of fire rated level or fire rating level and see if you can see what the different 60s stand for. They all have a meaning. FRL, fire rating level.
Structural integrity.
Yep.
And insulation.
There's 3. What was the first one again?
Structural integrity.
Yep.
Integrity. And insulation.
There's 3 aspects of construction. So they have to do their structural job, so walls keep the ceiling off the floor. 60 minutes, 60 minutes, 60 minutes. And I mentioned that earlier this morning. So the structural aspect of a building keeps the ceiling off the floor. Very important. Integrity is simply just staying in place. It's got to just stay where it's supposed to be. It doesn't necessarily have to do any structural work, but it just has to stay put, not explode out or melt or disintegrate or break apart. And insulation means protecting you from heat. So what they're saying is this spandrel or horizontal slab needs to do its structural, integrity and insulative work for 60 minutes under fire exposure. So if you can imagine, if those apartment buildings that had the fake cladding on the outside had have had horizontal spandrels, 1,100 wide, around each floor, that fire would have had a lot more trouble climbing the building, and all those people would have been saved. May not look overly attractive, but it's very safe. Now, what I'm going to show you, I think, just very quickly, so that's part A. Part B says the requirements of A do not apply to an open deck car park, an open spectator stand, a building which has a sprinkler system, openings within the same stairway, openings in external walls where the floor separating the stories doesn't require an FRL with regards to integrity and insulation, or if the window means that the part of the external wall building doesn't have to have an FRL of 60, 60, 60. So there's some exceptions there. Pretty unusual. Regardless, we would have a spandrel or a horizontal construction projection between our floors. Because we've got that repetition, the windows are going to be on top of one another. So I'm just going to show you a quick diagram of what that looks like in section from the guide of the NCC, and then we're going to check our drawings and see if we can make some assumptions about what we've got. So very quickly, see if I've got the guide. There it is. So in the suite of regulations that you downloaded the other day, you would have got Volume 1 and Volume 2, then the plumbing code, and then the guide, and it was the yellow one. Section C, fire resistance. There's some explanatory information. These are not further regulations. They're explanations to help you understand and interpret the regulations. So I'm just going to go to C2, compartmentation and separation. And I'm going to look to see, I have a feeling there's a very nice diagram of what the spandrel looks like.
So where are we downloading these from?
The Australian Building Codes Board. You would have downloaded them last year. They'll probably be in your cloud somewhere. There's a bit of information about the compartmentation and the size of the building. See, there's significant square metres. It's 18,000 square metres. And then it's a volume as well. It's not just floor, it's the third dimension of volume, because smoke is three-dimensional, and so you've got to compartmentalise. So if you've got a volume of 108 cubic metres, then you've got to isolate that and keep it limited. But I digress. There it is. Let's go with a single page. All right. So here is one story. This is the people's house, sole occupancy unit here. There's a window. This is the head of the window, the top. Then there's concrete. This is the floor, and this is the next apartment complex building floor here. There's a window. This is the top and bottom of the window. Then there's more concrete. Then there's another floor. So they're all stacked up, and the window location is repeated, and they have to be a minimum of 900 millimetres apart. So the top of the window here and the bottom of the window above have to be at least 900 millimetres apart, and this construction has to have an FRL of 60, 60, 60 for the fire separation to be compliant. And you can see this is a minimum of 600 between the top of the floor and the bottom of the window. So it kind of makes sense that that works out. The minimum, you can obviously have more, but that's the minimum to be compliant. If you want to break that rule, then you've got to find another way to show that you're compliant by separating that area off. So if you wanted really high windows and then really low windows, you wanted a full wall, then you might have to create a fire rating level of that. That would be a fixed curtain wall. So a curtain wall is a bit like those windows there, but more of them and larger, where there's big expanses of walls made of glass, and they call them a curtain wall. They have to be rated for fire protection, but you don't open those. You can't fall out. So, and you've got floor to ceiling windows, you can't open those, because if you open something low down, somebody might fall out, which has happened. So that's not about fire, that's different. But if you were to have windows that did come all the way down here, they would still have to have the same fire rating level. And you can get fire rated glass. So on the checklist you can see there, C2.6, spandrel required minimum 900 in height. So if you need a bit more information to explain that, or you want to make a note to yourself, scribble on that and just reference that's page 132 of the guide for the image, if you want to be able to find that. And if you were non-compliant here, if you didn't have this gap, you would have to add the horizontal projection, 1100 wide, wouldn't you, to be able to do that same work. So I've got a little note on my checklist that says, where non-compliant, according to that, horizontal projection to a minimum of 1100 as per NCC C2.6A. So I go back to our so a spandrel not less than 900 is then compliant. If we've got that, we have a tick and we can move on. It's got to extend not less than 600 above the upper surface of the floor. Remember that 600 millimetre dimension? And it has to be non-combustible material of 60, 60, 60. They're the three things we want to see. Or it has to be part of a curtain wall or a panel that complies with that. So a non-combustible FRL 60, 60, 60 curtain wall. Or construction that complies behind the curtain wall with this, or the horizontal. So there are our choices. Now if we have a look at our drawing, not on the ground floor plan, but if we have a look on the first floor plan, you will notice there is in fact some horizontal elements. You see those there? They're just narrow. There's no balcony there's no balustrading, there's no handrails on the outside. They're clearly open. It's an edge that you could fall from. They're not very wide. It's not like it's a pathway or a balcony or anything like that. It's called a transom. 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 Now, it's not for the entirety of the building. It doesn't go all the way around, but it's everywhere there are windows. So it would certainly contribute to some fire separation. It would also act as access for service and repairs to the outside of the building. Now, these are not everyday locations that you and I would go, but people who are able to work safely at heights have harnesses and connect to the building so as if they do fall off the edge, they don't fall to the ground. They could access the building, the outside of the building in that place, couldn't they? So it's quite a handy little area. It does both the fire separation that we need and also give workmen access and perhaps to the air conditioning. Because you'll notice there's a small rectangle just here. That will be the external unit of an air conditioning condenser. You've got one there, you've got one here on this little balcony, and you've got one here on this little balcony. So where the air conditioning, and there'd probably be three all lined up. It wouldn't just be one, it would be all the systems for the whole unit would all be lined up one above the other. So there's actually even some screening here, you'll have noticed, and even on the elevation, that actually stops the view of those machines so it doesn't look unattractive. So that's definitely air conditioning there. And this one's tucked in behind a wall, so you can't see them from the outside. So the facade of the building's still attractive. But you've got this access way where people can climb the building. Now, I don't think they're dimensioned, so we don't know if they're 1100 millimetres, but perhaps we could make a note on our drawings that they need to be 1100 millimetres to be compliant with C2.6. Wide, yeah, the dimension, the width. Yeah, from here to here. From the outside of the wall to the line needs to be a minimum of 1100 millimetres because that's what C2.6 requires. So what I want you to do is make a note of that on the drawings. You can't really change the line work, but if you make a text note, then when the revisions get worked on in the drawings, in the model, they can be checked and made sure of. So I would write, and this will take some practice, when it comes to drawing and writing and using drafting language, it can be a bit intimidating. We don't write with punctuation. We don't use joining words. We're very robotic with our language. I wouldn't say typical, but I would probably say as per. So I would say transom width, min, which is short for minimum, min 1100 as per, and bear in mind, if the unit of measurement is millimetres, you don't need to say it. If it's anything else, you do have to say it. But anything that's millimetres, you just say the number and everybody knows that's millimetres. Transom width minimum 1100 as per NCC C2.6, was it A? B. A1, I think it was, A4, something like that. Let me see. 2.6 A 4, A, B and C, just A4. That's what I would write. I would write that on the drawings, on the plans, the whole bit. Now, what we don't have is a section of where the windows are, like the diagram in the guide. We do have these elevations, so we're just going to have a quick look at those and see what that looks like. Let's have a look here. Where are we? Probably not too bad. They're a bit light, but that's not too bad. So you can see on this front elevation, we've got windows directly beneath one another, which is the phenomenon we're trying to protect. But you can also see there's quite a bit of distance between the bottom of the window and the floor beneath it. You see that there? Now, that's good for two reasons. It's really good because of the fire separation, because there's all that non-combustible concrete there that the fire can't penetrate. So even if the window's open, the fire would have to be an absolute raging inferno to get out of one window and go all the way up and inside the next one. So the likelihood that that's the case is pretty rare. The other reason why it's good, it's got nothing to do with fire, it's just an aside, it's actually good for energy efficiency because not only does that horizontal transom provide fire separation, but it creates a bit of shade under there, which can be really nice. Thermal protected shade, in fact. Now, when those projections, which ideally at least 1100 wide, and then that's good width for the servicemen and women, when those transoms project, they create shade at an angle down to the building. So the higher that the sun is in the sky, the further the shade comes down the wall. But as the sun comes down in the evening or comes up in the morning, it gets in underneath a little bit. So you're not going to get as much shade, and the shade creeps up the wall. But when you've got such a lot of solid wall here, it keeps the heat out for the duration that the sun goes up or comes down as best it can. So it's actually really smart to set the windows a little higher here in the tropics, because that lower shade in the morning and the evenings when the sun's really going up or coming down, not the daytime when it's high in the sky, but in the evenings and first thing in the mornings, can be quite hot. And if you've got glazing, if you've got windows down there, as well as for fire, it also lets a lot of just everyday heat in. So that's actually pretty wise as far as energy efficiency goes, as well as fire separation. That's just an aside. Now we've got these double doors here stacked upon one another. They're entrances from the balconies into the units, aren't they? Sliding doors. Remember the other day I mentioned that wall heights are 2.7 metres high and windows and doors finish at 2.1 metres high? That's 600 millimetres between the top of any opening, fenestration, doors or windows, above the header to the underside of the slab. So that's definitely 600 millimetres there and there. This could be anywhere between a metre and 1200 millimetres, I can't really tell. But there's definitely 600 millimetres there. Now there's no 600 millimetres above that like there needs to be in the standard, but the balcony is very wide, isn't it? The door is set way back, much further than 1100 millimetres. If you look on your floor plan, the doors that I'm referring to on every balcony are at least 3 metres from the edge. Where we're looking, front elevation, unit 2 and 3, let's go there. Nope. This is the elevation we're looking at, and I'm concerned about the fire separation where the doors are stacked upon one another, but look at the size of the overhang, so it's no problems. And then I've got windows over here, they're the same as the first side. So I go back to where I was. So we're protected on that elevation, aren't we? This is the rear elevation. There are some louver windows here, I think. Again, this is another little balcony. So we're at the back of the building now. There's the sliding doors there, accessing the balcony. And these are louver windows, but they're well set back. So they're protected as well, which is why the transom doesn't come out and around, because the balcony's doing the job. There's a ventilation toilet window. It's very little on the elevation. Can you see that there? Did you find the 900? I have a feeling it might say that. That's good spotting. Well done. So we really want that to be 1100, don't we? So that rear elevation, there's the toilet window. There's lots of protection there. The spandrel is very significant. No problems there, compliant. Then we've got the left and right elevations. You can see they're quite high set, narrow windows. That's ideal, again, for that same shade phenomenon that I'm talking about. So there's lots of protection underneath each window for fire separation there. And the same heights for the small ones. It's probably another bathroom. I think that's the ensuite. Then we've got, I think that might be, this is the lift shaft. There's the stairwell, so that's all open. And there's no need to worry too much there because they're not the occupancy units. That's just the common area. And then we've got these little windows here and something else going on there. So I'm just going to look at the floor plan. Oops, nope. So we've got windows, high set, they're the two high set windows. There's a little balcony and that's the double doors that I was just looking at. So that's protected because the width of that balcony will take care of the separation. And then there's a bedroom there with a window. So we're just going to have another look in elevation at that window for the bedroom. Do you get the idea of what I'm doing? I'm just being really systematic, just going around the building, having a bit of a look. And even without dimensions, I can predict, knowing what I know about construction, whether it's compliant or not. If there's any doubt at all, I just make a note on the drawings to make sure when I go back to the construction documentation, and if it's not correct, then I change it in the dimensions in the drawings. I actually would move the window. I would just say, this window needs to be higher up or smaller or move to the left or right. There's a few options that you could do to make it compliant. Where were we? So this bedroom here, I think oh no, this one here. So it's only high set. Plenty of protection for that one. And it's pretty much the same on the other elevation. They repeat each other. Remember, they're mirror and flip. So we're already quite compliant with the 900 millimetres between each opening, aren't we? And we have the projection, which apparently is only 900 millimetres. Whereabouts is that? You found it, did you? Where are we? Oh, this one here. No?
Go down. 900 at the end. Keep going to your...
Oh, this one. There it is. Quite right. Is that the one you spotted, Juan?
Oh, yeah. We both did.
Yeah, it's there. Quite right. So that is actually dimensioning this here. That's the balcony. And there's a little width there. They're just dimensioning. But it happens to tell us the same information. Excellent. So it's 900. That's fine. So as a pathway for servicemen, that's plenty wide enough. A doorway for a laundry can be 700 millimetres, so that's plenty wide enough for somebody to walk around the outside of the building when they're all harnessed and strapped in. It doesn't need to be 1100 because we are compliant with the actual spandrel requirements.
So if there is a window...
C2.6A. You're right, we're compliant. Go on.
If the spandrel wasn't 900...
Correct.
Have
the easiest way is the horizontal projection.
Yeah.
If that doesn't fit with the aesthetic of the design, then it might mean offsetting the windows rather than having them all lined up, or it might mean making the windows fixed and fire rated. So you turn the window into the same rating as the wall and it's not a problem, but you just can't open them.
So you could have your windows blow up, but you just have the strand.
Yeah, the transom or the projection. Yeah, the horizontal projection. Yeah. So there's a few different ways that you can get around it. Yeah. Nobody wants a window you can't open. But if it's fire rated, you can't open it. So it can be a bit tricky. Yeah, because as soon as the window's open, it stops being fire rated entirely. All right, so we want a little note on our drawings about that. In your own words, however you like, but do reference the code so that you know where to look. You can't write with a minimum of 900. You can say transom is currently 900 to comply, you know, and then because the minimum is 1100. So you might end up mistaking that later. Yep. C2.9, if parts of different classifications are situated one above the other in adjoining stories, they must be separated as follows. And for type A construction, which is what we're dealing with, the floor between the adjoining parts must have an FRL of not less than the prescription in Spec C1.1 for the classification of the lower story. So we're going to quickly go to Spec C1.1 and see if that can help us out. Here we go. Type A, fire resisting construction. Here it is. So being careful to make sure we're looking at the right type of construction, because there are different tables for different construction systems. And you'll want to take a note of this. This actually will answer quite a few of the next few clauses. The next few compartmentation and separation clauses all refer back to this table. So this is the fire rating level for different components of the construction of a type A construction building. And you can see there's different class buildings because they can all be very tall. If you have a hospital that's 12 stories high, it'll be something other than a class 2. It'll be, I think it's a 9B or 9C, but it will still be type A construction, the same as the one we're dealing with because of the height. So we're looking here, class 2, that's our project. For load-bearing walls, and we just have a note here saying external wall, including any column and other building element incorporated therein, which means inside, or other external building element where the distance from any fire source feature to which it exposed is less than 1.5 metres, 1.5 to 3 or more. Now, let me just click on fire source feature because it's about proximity. The fire rating level has to be higher if it's very close to a fire source feature. So I'm going to click on that and show you what that is. So a fire source feature means the far boundary of a road, river, lake or the like adjoining the allotment. So the boundary, if it's within 1.5 metres, potential fire sources from the neighbours can be 1.5 metres away or between 1.5 metres and 3 or more than 3. So that's about the proximity. To the side or rear boundary of the allotment or to the external wall of another building. So that's about the proximity of where fire can reach you from someone else. More often than not, you'll see a lot of projects and they'll just say, get 3 metres away from the boundary. And then really a lot of this stuff stops being necessary. But if you've got a wall, an external wall within 1.5 metres or 3 metres of the boundary, it all has to be fire rated, which might mean extra construction costs. So if there's no need for the boundary to be so close, then you would just restrict that. Let me just go back to where we were. So if the load-bearing wall is less than 1.5 metres to the boundary, the fire rating level has to be 90, 90, 90 of the construction system of the external wall. What are our external walls looking like? We have a site plan. Do we have any dimensions? No, it's generally about, because they're much quicker than that, it's generally about how long the structure, the integrity and the insulation of the building will last under fire conditions. So that's about people being able to exit under their own steam. But yes, the fire brigade should be able to do their job within that time as well. Yeah, so it's a little bit about them because they don't want to be doing their job and then that 90 minutes pass. But they would probably use that as a gauge as to whether to enter or not enter the building, knowing what the regulations are. But they still have to make a judgment on the day, I expect. The tricky part with class 2 buildings, particularly very tall ones, is that you have to have an exclusion zone around them under fire conditions because windows like that, like the ones I'm pointing to there even, they're not mechanically fixed. They're not screwed or bolted in, they're just glued. It's just tape and glue. I mean, it's excellent glue, don't get me wrong, like really excellent glue. But it's glue nonetheless, and it melts in a fire, and the windows simply just fall out. So you have to stand back. So I'm going to give you some dimensions for the building to the boundary, because the ones on the site plan aren't as clear as I'd perhaps like. I can see there's a 4145 on the south side. Can you see that there? 4 metres, 145 millimetres, that one. So we're definitely beyond 3 metres from the boundary on that side. At the rear, 3570, can you see that? So at the top, it's going to be 4 metres as well. On the north side, the distance from the lift shaft to the boundary is 4 metres. A minimum of 4 metres. It might be a little more, but a minimum of 4 metres. I'll point to it on the board for you as well. So here we've got 4145 here, 3570 here. This will be 4 metres, and this dimension is a minimum of 8.5 metres. It might be a little further, in fact, but a minimum of 8.5 metres. And that's more to do with the planning scheme, but I just thought I'd give you that information so that you knew it for this exercise as well. All right. So, to the elevation, yeah. I think the one at the bottom there, the 4145, looks like it's to the elevation, not to the transom. So it's a minimum of 4 metres to the transom. So you can already see our external walls are greater than 3 metres from any fire source feature. So they don't actually have to comply with this. They probably will anyway because of their natural construction. Concrete has a very high fire rating level. We'll come across that shortly. But if you want to make a note of it, let me just see what I've got on my notes. So on my checklist, I've just had a bit of a list and I've written load-bearing walls 90, 60, 30, which is this figure here. Because it's 3 metres or more, it has to be, sorry, I misspoke when I said it didn't have to be compliant, that's not true, but it has to be compliant with 90, 60, 30. So the structure has to last 90 minutes, its integrity has to last 60, and its insulative effects have to last at least 30. Now you'll notice for non-load bearing parts, there's a dash at the front here. You see that there? The first part is the structural integrity. It has to keep doing its structural work, but a non-load bearing wall isn't doing any structural work. So it gets a pass on the first figure. It still has to stay in place and it still has to do its insulative work, but it doesn't have any structural performance. And you'll see doors and windows have the same phenomenon. Now, as our load-bearing, our non-load-bearing parts are obviously going to be 3 metres or more away from a fire source because they're on the inside of the building. We don't have any on the outside of the building. I think we've got some carport structures, but they're closer to the boundary. But there's no requirements for that at all. If they're more than 3 metres away, you're off the hook. Dash, dash, dash. Just scroll down briefly there. The next category is external columns. So we've got columns in our carport, haven't we? Where the cars will drive, where they first come in. For load-bearing columns, they have to maintain their structure for 90 minutes. They don't have any integrity or insulation requirements, which makes sense because they're just a column. So I would make that note, load-bearing columns, 90 dash dash. We don't have any non-load-bearing columns. If we did, we would take them away because we just don't want to pay the money to build something that doesn't have to be there. $90 dash dash for load-bearing columns. Now, something to consider, because this is an open common area where we are moving between the downstairs and the upstairs, this is just circulation space, this is not going to be protected by any walls, it's open, so it's not fire rated at all. So this wall here is an external wall for that unit, isn't it? It's not just around the outside. This is a partition between one set of units and the other two. So this is actually an external wall here, something to remember. So if you wanted to highlight that or colour it in red or do something like that, that might be a way of prompting and letting you know that that FRL's got to be, is it 90, 90, 90? External walls? Yep. And it's load bearing for sure, because it's holding the concrete above. This will then also be an external wall all the way around.
So that's what you call an envelope.
Yeah, that's good. I like it. But we also have this wall down the middle here. And we talked about that earlier, about that separating the two units off. So that's a common wall or a separating wall. And you can see it comes all the way through the balconies as well, because you don't want combined balconies when you live with somebody next door. So that has a fire rated level of its own as well. Go back to our NCC. Common walls and fire walls. Fire resisting lift and stair shafts, load bearing. So our lift shaft will be load bearing, needs to have an FRL of 90, 90, 90. So that shell, the wall, and it's hollow all the way up. So it's really important that that's fire rated, because if the fire gets in there, it will travel up the whole building because it's just a big chimney. We don't have any non-load bearing lift shaft walls. Bounding public corridors, public lobbies and the like. We don't really have any public lobbies. There isn't a nice entrance to our building. It's simply just drive in and get out of the car and take the stairs up the back way. So it's not one of those kinds of apartments. It's a bit more economical than that. But bounding public corridors. So if our public corridor was sealed off with walls, they would have to have an FRL rated wall. We don't have that though. And between or bounding sole occupancy units. So our common wall is definitely load bearing because there's concrete above it and it'll be holding that up. So load bearing between sole occupancy units also has to be 90, 90, 90. And then just a little further on the page, the last couple of building elements, we've got other load-bearing internal walls and internal beams and trusses and columns. We don't actually have any of those, but if we did, they would have to stay the 90, the same as the columns. There perhaps might be some structural systems between the columns underneath the main transfer slab, but that'll be up to the engineer. If that's the case, they'll need to be 90. The floors need to have an FRL of 90, 90, 90. And the roof has to have 90, 60, 30. So we'll have a similar roof as floor, so it'll already be adequate if it achieves the same as it needs to. We've got a concrete floor and a concrete roof. So they're behaving very much the same as the external walls and the separating walls. They all need to last an hour and a half. C2.8, separation of classifications in the same story. I think we've just taken care of, so we should probably go back to that, because that's what led us here, wasn't it? So each building element in that story must have the higher FRL prescribed in the specification. So if we had columns and floors and external walls that all had different FRLs, whichever one was the highest would be the separation requirement. They're all 90, 90, 90, so everything has to be that. There it is there. C2.10, separation of lift shafts. Any lift connecting more than 2 stories, so we have that, or more than 3 stories if the building is sprinklered. So if you've still got sprinklers and it's more than 3 stories, the lift shaft must be separated from the remainder of the building by enclosure in a shaft, which in a building required to be of type A construction, which we are, the walls have the relevant FRL prescribed by the specification. And the specification said 90, 90, 90. So it's got to have its own room, which it does, and you can see on the drawings. On the plans, you can see there's a double line thick wall around the lift, and it's got that hatch pattern that I just talked about. So you can make a little note on the drawing saying lift shaft separation required, and it's compliant. And it'll be on your checklist as well. It says C2.10 lift shaft to be separated. And you can say compliant next to that, can't you? Because in the design, that's already correct. Now if I scroll down a little bit, there's some information about stairways and lifts in one shaft. So if you had them combined, you would have to treat them carefully, but that's not the case for us. But C2.12 is about separation of equipment. So equipment other than is described in B and C, so that's further down, must be separated from the remainder of the building, with construction complying with D if that equipment comprises lift motors and lift control panels. So with our lift, there's a motor that operates it, and that needs to be separated and protected from fire as well. We don't have any emergency generators. An emergency generator might be a water pump that pumps water out of the basement if we had an underground car park, or it might be an emergency generator that kicks in for life support equipment in a hospital or an aged care building where there needs to be a maintenance of electricity in an emergency, or it might be that the lifts have to work in an emergency. Maybe the building is really, really, really tall and expecting the fire service department to use those stairs is ineffective. So they have an emergency lift that is operated by an emergency generator. You would want to protect those mechanisms from fire. So that's what this clause is about. On-site fire pumps need to be separated, and then there needs to be FRLs as per the specification, but not less than 120, 120, 120. So for our lift motors, C2.12, lift motors will need to be separated by an FRL as required by Spec C1.1. I would imagine that would be the 90, 90, 90 that we've been asked for our lift shaft. But perhaps it's the 120, 120, 120. I'm not sure now. I'm doubting myself. Oh, there it is. Yeah, no, I think I'm right. So on the checklist it says lift motors, FRL 120, 120, 120, and control panels. So separating construction must have an FRL required by the specifications, but not less than 120, 120, 120. So to separate the lift motor, it needs to be a greater FRL. I'm not happy with that. I'm not as confident with that as I'd like to be. So that might be something that you would check with the boss. I've got lift shafts and stairwells at 90, 90, 90, and then I've got lift motors at FRL 120, 120, 120. No, you're right. Do you need a hand?
I had a question.
Yeah.
Load-bearing external walls.
Yep.
I got 90, 60, 30.
Okay.
It's meant to be 90, 90, 90, right?
Load-bearing walls. No, 90, 60, 30 was right.
Oh.
Because they were further than 3 metres from the fire-resisting source.
That's probably because I thought you said like
Yes,
everything else.
I did say 90, 90, 90. You're right. Yep. It'll be better than that anyway, but that's the minimum. What were we going to say?
And the lift motor.
Yeah. 120, 120, 120. Yep. But I'm not as confident with that as I'd like to be. This one?
Yeah.
Yeah.
So when it says 3 to less than 9 meters,
Yep.
for each level, is that what it's talking about?
No?
So this is what we're looking at. Right?
Yep, class 2.
Yeah, class 2. So we're looking at that.
Yep. So
Class
it's
2 less than 3
the
meters.
external wall
Mm-hmm.
or other external building element where the distance from any fire source feature to which it is exposed is 3 to... No, you're in type B construction.
Okay.
You want type A.
Yeah.
I was going to say that doesn't look the same. Keep going.
Okay.
Keep going.
That's
There you go.
Mm.
Keep going up a bit. So, which it is 3 metres or more away. So we looked at our site plan and our walls are more than 3 metres away from the boundary.
Yeah.
Remember the fire source feature is the boundary and what's over the boundary.
Okay, so that's what the sign
So
is.
it's 3 metres or more away from the boundary,
Yeah.
so that the FRL for class 2 external walls is 90, 60, 30. Yeah, you got it. Now, I've just got a little note in the checklist there. Floors to achieve FRL 90, 90, 90 and penetrations to be fitted with fire collars to 90, 90, 90. Now, I was just having a quick scan around in the specification to see where that came from, but I can't find it off the top of my head. But basically what that means is when you've got a floor slab, so a solid piece of concrete with no holes in it, which is what a penetration is, when you've got a solid piece of concrete without any holes in it, it's fire resistant and impenetrable. But unfortunately, in modern day construction, you do need to put holes in concrete slabs because pipes have to go through or electrical conduits have to go through. You have to move the plumbing through the whole building, all the way from the top all the way down. And it's not particularly attractive to put it on the outside of the building. So they generally just go through the slabs to do that, which is perfectly fine. So you can get a collar that goes around the pipe that prevents the fire from getting in through the gaps. And they're rated as well, those fire collars. So if you have to cut a hole in the concrete, you have to protect that from fire penetration as well. Totally fine.
What about like the sewage pipe? Because obviously sewage contains methane.
Yeah.
Is that
It doesn't stay in the pipe though.
I know, but if
The likelihood of the timing would have to be pretty bad.
yeah, but the wall.
I'm just thinking about the guy in the toilet and the fire and, you know.
Yeah. I was just saying, like, if there was a fire, it has to be contained in a wall where it's like a fire rating?
Normally you would just cover it up for aesthetic purposes, but it wouldn't necessarily be about fire rating, no. No, but the covering up, yeah, I would be impressed if there was enough methane to be a problem.
Yeah.
Yeah. And because we've got fire, water traps in the toilets to stop the gases getting through, then it's not really an issue. Hopefully it's not an issue. Yeah. You have to be pretty unlucky. That's a good question though. All right, where were we? Oh, C2, done. Phew. Might just grab a drink of water, a bit croaky. C3 we want to look at now. Just going to shut that part. Is everybody sort of clicking on the NCC as they go? You're having a bit of fun, having a bit of a play around? Excellent. It's just a good first go at navigating. This is actually much better than it used to be. In the online versions it was not very easy to use in comparison, believe it or not. All right, part C3, protection of openings. I'm going to skip the deemed to satisfy provisions and the application of the part. Protection of openings of external walls. Let's see if we have to protect any of our openings. Openings in an external wall that is required to have an FRL, so our external walls are required to have an FRL, the 90-60-30. If there are openings in that external wall, if the distance between the opening and the fire source feature, so the boundary, if the distance between the opening and the boundary to which it is exposed, so the elevation and its corresponding boundary, not elevation 3 and elevation 4's boundary, that's miles away, we're talking just the same elevation and the same boundary. If it is less than 3 metres or 6 metres from a far boundary of a road, a river or a lake, or 6 metres from another building on an allotment that is not class 10, it needs to be protected in accordance with C3.4. And if wall wetting sprinklers are used, they are located externally and, if required, blah, blah, blah. So we can stop reading there because we don't have wall wetting sprinklers, so we can stop there.
Would that only apply to the houses that where the fire?
The wall wetting sprinklers? Probably not. There's probably quite a few places that have it, but they would definitely apply there if they've got them. So openings in an external wall must also have an FRL if they are less than 3 metres from the boundary, or less than 6 metres from the road, or less than 6 metres from another building. Do we have that indication for us? We don't, do we? It's further than 3 metres away from the boundary. So our openings in our walls don't have to have the same FRL as the walls do. So even though the wall under 3 metres or more, the external walls had to have an FRL of 90-60-30, the openings don't have to. Which is helpful because you wouldn't be able to, if they were fire rated openings, you wouldn't be able to operate the windows. They'd have to stay shut and there'd be no ventilation in our house. So that would be bad. And that would make us non-compliant with a few clauses later. So because we're 3 metres from the boundary, we don't have to make our openings fire rated. We're beyond 6 metres from the front boundary. Remember I said it's a minimum of 8 metres from the front boundary, so we're beyond 6 metres for the front boundary and the road, and we're beyond 3 metres from the boundary. So that's the sort of thing you want to make sure stays in place as the design progresses, so you want to put that on the drawings. And don't forget to quote the clause, as per NCC C3.2, A, because here it is here, as per C3.2A. So you'd probably say something like maintain distance of openings from boundary as per. guys are doing really well. Oh, I scrolled past, sorry. C3.2A is what we're compliant with. And if you want to put a little note to yourself, just put page 106 on the checklist for yourself. All right, so the last couple of clauses of section C are not related to our project. The separation of external walls and associated openings in different fire compartments. So we didn't need the fire compartmentation because we've got the sole occupancy units. And then there's some acceptable methods of protection. Actually, that might have the penetrations I was looking for. No? What is it?
Oh no, I downloaded it onto that computer.
What? Downloaded what? The NCC?
Yeah, that's easy.
You didn't upload it to the cloud?
Oh, I did.
Yeah, well, it'll still be on this computer.
Oh yeah, no, because my page is different to your page.
Yeah,
Oh, that's because the PDF and the number on the document don't match up.
Well, but
So,
for example, you're on page 7, we're on page 9.
Yeah, I'm on page 9.
I'm the same as you.
really?
Yeah, sorry, I interrupted you.
That's so weird. No, it's quite okay. Isn't that interesting?
Changed in the last year.
Yeah, I downloaded this last year. Yeah, there it is. So there's probably a couple of introductory pages and you've got that. Well, I won't quote Dave.
What page is it on the actual document?
107 on the document. It might still be.
So 107 on this document, scroll up a bit. Okay, yeah.
Does it match up with the content?
No, it doesn't.
Before it didn't, now it does. When you look on the table, when you scroll to that
Oh,
table,
okay, it
it's
was a
completely
different page.
My page is
Wow, that's a bit trippy, isn't it? All right, we'll have to be careful.
mine's 80.
It's probably just a new page at the front or something. Yeah, welcome to the NCC or something like that. Yep.
Now it was, now it is before.
Now it is. Now it isn't.
Anyway, it doesn't matter.
That's all good. Sliding fire doors. So there's a bit of information about those. Protection of. Oh yeah.
They have their own little weird foot
They do, don't they?
especially with residents.
Oh, really?
Protection of doorways in horizontal exits. So a horizontal exit is an exit that you stay on one level on one side of the door and it's the same level on the other side of the door. There's no stairs, there's no ramp, it's just the same. So you're moving in a horizontal platform. It took me ages to figure that out. Oh, what on earth's a horizontal door like? Am I? It's a hatch in the ground or it's what? Nope. That's all it is. An opening is in fire isolated exits. Whew. Oh, look at this, what I've just found.
So that, hang on, openings in a fire isolated exit.
Yeah.
That would be,
We don't have a fire isolated exit in this building.
but there are some stairwells and that sort of thing that would be.
Yeah, it's,
I'm pretty sure our old unit was.
yeah.
Stairwell was completely enclosed.
You know, in the library here, yeah, some apartment complexes do have those, yes. This one doesn't, but some do. So you go into the stairwell, you shut the door behind you, it's heavy and it slams hard, it's all concrete, there's no windows, and you go down the stairs and then you come out at the bottom. Very common internal fire isolated stairs. These ones are open and it's not isolated, so it's different, but that's what that is, yeah. And there's one in the set in the library down there. They're awful. Hey? It's sort of treated the same, but it's got its own category. Yeah, so it's just the isolated lift shaft. Now, I was just scrolling happily, scroll, and I came across something I've never seen before, which is a bit cheeky. Look at this C3.11, bounding construction. So I'm flying blind here a little bit, people. You have to forgive me, so I'm going to figure this out as we go. It says Class 2 and 3 buildings and Class 4 parts. So 2 is sole occupancy units, 3 is transient accommodation, and Class 4 are caretakers accommodation in other building parts. A doorway in a Class 2 building must be protected if it provides access from a sole occupancy unit to a public corridor. So that means, and that, of course, So the door that leads from the sole occupancy unit out into the open corridor needs to be fire rated. The same as the external door, I'd expect. That's about the only. So if it goes from one sole occupancy unit into a public corridor or into a room that is not within the sole occupancy unit, I can't think what that might be, maybe a storage room or something that's sort of outside of it. The landing of an internal non-fire isolated stairway, which is kind of similar to the public corridor for us, or into another sole occupancy unit. Now in a class 3, that would be those connecting doors between hotel rooms, you know, where it's locked for if you're separate and it's open if you're joined. That would be one of those doors. So it must be protected. And a doorway in a Class 2 building must be protected if it provides access from a room not within a sole occupancy unit into the public corridor. So if you go from your unit to a storeroom and then from the storeroom into the public corridor, it's got to be protected there too. See what else it has to say. Or to the landing of a non-fire isolated stairway, and then it says Class 4. Protection for the doorway must be at least in a Type A construction, a self-closing door with -60/30 fire door. It's good stuff. Glad I bumped into this. So dash means that it doesn't have any structural integrity. Remember, these are the 3, structural, integrity and insulation. Doors don't do any structural work. They can't. It can't hold anything up because it's too busy moving. So it'll be -60/30. So it'll have to be a fire door for the main front door of all 3 occupancy units, and they have to have closers on them. Yeah, doors and windows are always dash. So we better, I'm going to have to add that to my checklist. Gosh, heavens forbid. That was a handy little scroll. So that's C3.11, sole occupancy doors, FRL dash 60/30 with self-closing mechanism. That's so it shuts behind you to maintain that fire rating level. If the door's open, it's not going to do any fire protection whatsoever. That's why you often see people in trouble when they prop open fire doors. You're not supposed to do that. If there's an automatic closer, the door is supposed to close behind you.
And then note that the ones at the entrance to the stairs, the isolated stairs, they close a lot faster than the ones at the front door.
Do they?
Yeah.
Yeah, right.
That's my building that I stay with.
It's a heavy. Yeah, right.
Yeah. So that the fire doesn't get in.
So as per 3.11, A and D. Cool. Good job. That wasn't quite as difficult as I thought it would be. How are we doing? Do you need a little cup of tea? Yeah, quick toilet break? Absolutely, because we're about to go on to D. The NCC will do that.